Now let us see their physical properties. See, alkyl halides or alkyl halides basically are colorless, either liquids or maybe the solids, and very smaller ones are actually our gases. Now mainly they are colorless, but what we find is the alkyl bromides and alkyl iodides on actually long standing or we have old samples of these compounds, they develop color, mainly because of the formation of the bromine and the iodine. Now let us see first in the physical properties their melting point and boiling point. Now what we find is, what you need to understand is that methyl chloride, ethyl chloride, methyl bromide, like these ones are gases, or chlorofluorocarbons we know, which are also called freons. They are the ones which are gases. Other than these, all alkyl halides are actually liquids or maybe the solids. Now what we find is all these compounds actually are polar in nature. We need to understand that the CX bond is highly polar. As a result, they easily develop strong dipole-dipole interactions. Now as a result of this, what we find is they have higher boiling points than the corresponding hydrocarbons, because hydrocarbons have dispersion forces, but they have dipole-dipole interactions, which gives them a higher boiling point. Now what we need to know next is that among the different alkyl halides, the boiling point decreases with decrease in atomic number of halogen. So it means what? Alkyl iodides will be having the highest boiling point, followed by alkyl bromide, then alkyl chloride, and then alkyl fluorides. This is because the larger is the size of the halogen we have, or along with the alkyl halide, the larger the size becomes, more stronger will be the surface forces, the van der Waals forces. That is why what we say is that they have their boiling point decreases with the decrease in the atomic number of the halogen. Then among isomeric alkyl halides, if we have to compare, like suppose we want to take the example of CH3, CH2, CH2, Cl, and then we have, this is N-butyl chloride. This is what we have is, then we can have isobutyl chloride, and then we have is tert butyl chloride. Now what we find is the surface area is maximum with this alkyl halide, whereas it keeps on becoming more and more spherical. The more spherical it becomes, what we find is the lesser is the surface area, so lesser will be the boiling point. So that is why what we say is boiling point decreases in this order as the surface area decreases. So this is having the larger surface area, so maximum boiling point. So among these isomeric alkyl halides, what we find is it decreases with the more the branching the alkyl halide is having. Now after seeing these alkyl halides, let's talk about something about the aryl halides. Now what we find is aryl halides also are polar in nature. Therefore even their boiling points are found to be higher than the corresponding normal benzene or aromatic compound. The reason being they develop dipole-dipole interactions. But yes, what we find is, like if we are talking about among isomeric dihalo derivatives, like suppose we have these two derivatives like orthodichlorobenzene, metadichlorobenzene, and paradichlorobenzene. So among this ortho, meta, and para, what we find is its dipole moment is this side, this dipole moment is this side, so net gets cancelled, so net resultant dipole moment is 0. Whereas this dipole moment is towards this side, this is towards this side, but angle is, since is very large, is about 120 degree, whereas in this case, this is towards this side, this is towards this side, but angle is 60 degree. So we know that the resultant dipole moment is inversely proportional to what? Is the theta, the angle. So what we find is the ortho is having higher than meta, and then meta is having higher than para, so which is having 0. So this is how we find out that their boiling point and melting point varies. Now let us see their densities. Now in terms of densities, what we find is like alkyl bromides, alkyl iodides, and polychloro derivatives have higher density than water. So they settles down and forms a separate layer. The reason being because of the high atomic masses or molecular masses, because of the bromine, iodine, and the number of chlorine they have. But monochloros are having lesser density than water, so they float. Now this is what is the basic difference between they are having with respect to the densities. Now let's talk about their solubility. Now what we need to know is, see, they are very little soluble in water. In fact, we can say that they are not soluble in water, and because they are not able to form hydrogen bonding with water molecules, nor they are able to break the hydrogen bonding of the water molecules, or in spite of being polar, they are not able to form such kind of strong hydrogen bonding interaction with the water molecules. That is why what we say that they are insoluble. Whatever the little amount they are soluble, it is because of the dipole-dipole interaction with the water molecules. And same as with the aryl halides, which because of the bulky phenyl group or benzene ring, they are still more or less soluble than the normal alkyl halides, and then we say that they are not soluble in water.